Lead-2 bromide is an ionic compound. It consists of positively charged lead ions and negatively charged bromide ions. When solid lead-2 bromide is heated, the crystal lattice breaks and all the ions are now free to move in its liquid state. When an electrical current is applied, the electrodes become positively and negatively charged. The free-moving positive and negative ions in the molten lead-2 bromide are then attracted to the respective electrodes. The negative ions release electrons at the positive electrodes, while the positive ions accept electrons at the negative electrodes. By doing so, they create a flow of electricity in the outer circuit. This flow of electricity is being confirmed by the lighted bulb. We now know that liquid ionic compounds have free-moving ions in them. Thus, they can conduct electricity in their molten and aqueous forms. Do you think a covalent compound can conduct electricity? A covalent compound, such as naphthalene, is made of molecules. These molecules do not have positive or negative charges. They cannot ionize in water too. When an electrical current is applied, the positively and negatively charged electrodes cannot attract these molecules. There is no electrons transfer at the electrodes and thus no current flow in the electrical circuit. Therefore, the bulb will not be lighted. This is why most covalent compounds do not conduct electricity in the solid or liquid state. An ionic compound is made up of positive and negative ions. These positive and negative ions attract each other and group together in a giant structure called crystal lattice. In the crystal lattice, each positive ion is surrounded by several negative ions. In turn, each negative ion is surrounded by several positive ions. In order to melt an ionic compound, the forces that hold the ions together must be overcome. Since there is a massive number of ions present in an ionic compound, the overall value of the force between ions is very great. This makes ionic compounds have very high melting points. For example, sodium chloride has a melting point of 800 degrees Celsius. The covalent bonds inside the molecules are very strong. The molecules do not break apart easily. However, the forces attracting neighboring molecules to each other are very weak. It is therefore very easy to separate molecules from one another. When a covalent compound is melted, it is the forces between the molecules that are broken. These intermolecular forces are generally weak, and so melting points of covalent compounds are low. For example, the melting point of naphthalene is 80 degrees Celsius. As you can see, the water molecules work their way in between the positive and negative ions, separating them, thus dissolving the salt. In this way, the forces between ions are broken and all the ions are now free to move. All of the salt dissolves. But this is not true for sodium chloride in ethanol. The ethanol molecules could not separate the ions in the crystal lattice. Thus, the salt is not soluble in ethanol. In general, we can say that most ionic substances are soluble in water, but insoluble in other organic solvents like propanone and ethanol. As you can see, the water molecules could not work their way in between the naphthalene molecules. That is, the water molecules could not separate the naphthalene molecules, thereby could not dissolve the naphthalene. The ethanol molecules work their way in between the naphthalene molecules and separate them, thus dissolving the naphthalene. We can say that covalent compounds are soluble in organic solvents, but insoluble in water. In general, the solubility of covalent compounds is the reverse of ionic compounds. Liquids that dissolve substances are known as solvents. Covalent compounds with carbon atoms which have this property are called organic solvents.